Okay, guys, this is day 6. Let me share my screen. Okay, so we are going to day 6, and this is going to be the last stuff for the quadratics unit. And that's it. So just like that, in 6 days, we covered 2 units. See how fast this like goes? Like it really goes fast. So like it's important to be on top of it because you can easily fall behind. So hopefully most of you guys are not falling behind. So let me go through the line acknowledgement. We acknowledge we're hosted on the lands of Mississauga of Anishinaabe and Haudenosaunee Confederacy and the Wendat. We also recognize enduring presence of all First Nations, Métis, and Indian people. Okay, so July the 11th, Tuesday, we're talking about transformations, putting it all together, looking at zeros of the quadratics, linear quadratic systems. And then there's a quiz that's due today. You get two chances. There's also a formative review quiz for all that's done for this quadratic unit. We're going to technically call it unit. It's technically called unit in the system is unit 3, but it's actually unit 2. Okay, so I'll just start saying unit 2 because that's the first thing, the second thing we're doing. So this is unit 2. So again, unit 2 functions, quadratic functions test is given out today. Test is due on Wednesday, 11:59 p.m. So I hope everyone has submitted their other tests. I know it will, if like, it just needs to be submitted, okay? Because at some point I'm gonna have to mark and give it answers. And once I give it answers, then you can't submit nothing. That's how it is, right? So please work on that. Let me look at it as a student just to make sure I can see what you guys can see. So quizzes, let's make sure that you guys can. Okay, so the review 2 happening now.
Hindi ko ako ganun.
Please mute.
Hindi ako basta-basta.
And worksheets, you know, keep handing the worksheets. And then there's the unit 2 test that's happening right now. Okay. After this, after our session this morning, you can start working on that test. But I would do things in order. I would do the quiz because quiz counts. I would do the quiz. I would do the review to see how much I know, right? Even though it doesn't count for marks, I still do the review. And then I would then go into doing the test. So let's get into the lesson today. Okay, so intro. Okay, so transformations of x squared. You don't see the test and assignments? Refresh your screen, please. Refresh it. Because I made a mistake. It said 11:59. It should have said 12:01. Okay, so refresh it. You should be able to see it now. And let me know if you see it, okay? Erica, thank you. So transformations of x squared. Well, x squared we know is a quadratic, right? Right. So we say transformation. This is what we're looking at here. There's y is equal to x squared, and then transformation moves up 2, and then it's stretched by a factor of 3, vertically stretched. That's an example right there. So let's go into the video for that. And I think there is another lesson, which is more transformations. Oh no, sorry, this is a PDF, my bad. And then this is solving for the x-intercepts, right? For a quadratic. And then this one here would be using the quadratic formula. If you can't find factors, you can use a quadratic formula to figure out the answer. Okay. And is there another one? Oh, this one here is like a lot of stuff. This is where you have a linear quadratic system. So where does the linear line and the I guess the parabola intersect? Okay. So it's a lot here. I'm seeing how if we can cover everything, but we'll try. If I can't, then you guys can do the rest on your own. So let's start with the video lesson for the first one.
What? Still searching YouTube for math help? Are the videos from 2006 really helping? Aren't you tired of
Previous lesson, I explained to you what these parameters.
So you guys can hear it, right? Just want to make sure. Okay, good.
What these parameters A, K, D, and C do to transform the equation of f at x to get our transformed function g at x. And I explained to you the f at x we call the parent function, g at x is our transformed function. They're going to look similar, but depending on what the A, K, D, and C parameters are, the graph of the transformed function could be shifted left, right, up, or down, or it could be horizontally or vertically stretched or compressed, or there could be horizontal or vertical reflections that have happened. In the previous lessons, I explained how we can use A, K, D, and C to figure out exactly what transformations are happening. What I'm going to do in this lesson is we're going to apply that information to be able to do transformations of 3 different parent functions. So we're actually going to define f at x now. Our parent function, f at x, we're going to do 3 different functions. I'm going to look at, first of all, the quadratic function x squared. We'll look at that parent function. We'll also look at a different parent function. We will look at a new one. It's called the radical function root x. And lastly, we'll look at a type of rational function, the function 1 over x. We'll look at what.
Okay, so basically what's going to happen is the transformation, these are the parent functions, right? I believe this one may be on the test. This one and this one would be on the test as far as like a transformation. Someone keeps coming in late. Okay. So, but the transformation works the same way, right? If you have a parent function and then you apply the transformation. So for example, if you have a plus c, right? Then, and let's say it's plus 3 over here. Then if this is the parent function, this would shift up 3, right? And if this was the parent function, this would shift up 3. And if this was the parent function, this would shift up 3. Okay. So, and then again, say there was a value there. So maybe call that, maybe that was a 2, right? So that means it stretches on the vertical, on the y-axis. So this will stretch on the y-axis, this will stretch on the y-axis, this will stretch on the y-axis, okay? So it applies the same way. So let's continue.
What do these 3 parent functions look like, and how can we apply our knowledge of the parameters A? The parent function is f at x equals x squared. Let's graph the transformed function g at x, which is equal to f.
Okay, so you have, so this is g of x, and then basically this is the transformed. So you're gonna have that half means, well, first of all, that negative there, right before the x, it's gonna be horizontally imaged, okay? And then the half means it's gonna shrink by a factor of a half on the x-axis. And this one here, this is -1. That means it's going to move to the positive way, to the right. Okay. So I'm just saying it verbally, but we're gonna see it all happen right now.
F of x, but with parameters k equals -1/2 and d equals 1 applied to the parent function x squared. So before we apply the transformations, let's just have a quick reminder. What does the function f of x equals x squared even look like? What does the parent function look like? So let's make a table of values for f of x.
Okay, we can kind of skip the table of values because we can graph that. He's just graphing what is x squared. We can do that. That's easy. We're focusing on the shift of it. Okay, so now he graphed it. Now let's do the shift, the transformation of it.
The most difficult transformation to do. K is going to tell us that in this case, it's going to be horizontally stretched by a factor of 1 over the k value. So 1 over 2, which is going to give us a k. It's going to give us a horizontal stretch by a factor of 2. We always flip the k value. So horizontal stretch by a factor of 2. And the negative tells us there's going to be a horizontal reflection. I mean, for a quadratic, since
even though, like, okay, the negative, when it says a horizontal reflection, because we're dealing with a parabola, and if we rotate it like about the y-axis, it doesn't change, right? It looks the same. It's symmetrical, so it doesn't really change, right? Now this one's saying it's stretching by a factor. So what happens is your k is a 1/2, but your factor is 1 over k. So 1 over k gives you a value of 2 because this is a half. Now a half, basically, since the factor is a number that's greater than 1, that means I'm stretching. So I'm basically stretching this horizontally, okay? It's gonna look like it's like being pulled apart, like this way, okay? So that's what's happening with this. And again, with the 1, it's shifted over to that side. So let's see if we can look at it. There you go, horizontal stretch of a factor of 2, horizontal reflection means it just rotates about the y-axis, okay? So what does that mean? When we are looking to get the new value of x, because our k is a half, our factor is 2, so that means we're going to multiply x by 2, okay? Actually -2, to be honest, because there's a negative there, so -2. So each value of x, you're going to multiply by -2, right? And that will get you your new value of x. So you're going to plot it. And then also too, you shift it on the x to by +1. So you're going to multiply the number. So this is an example right here, right? What's this value of x? This is 1, 2, 3. So this value here is 3. Okay. So the new one is going to be -6. So if we count 1, 2, 3, 4, 5, 6, and then, oh my bad, I'm doing it the wrong way. X, we're going to go horizontally. Okay, so I made a mistake there. Horizontally. So if this is 1, 2, 3. Okay, so it's -3, and I multiply by -2. It's going to switch. It's going to go this way. It's going to be +6. So this one here moves over here to +6. Plus I add 1, so I'm stretching it even further. Okay. Rather than me just drawing this on the screen, I'm going to fast forward a little bit so you can actually see what it looks like. He's going to basically plot it So you can see here, he's gonna plot it, so you can kind of see that. So all my X values are gonna change by -2 + 1. And then my Y values, nothing changes because it was no effect on the Y value. Okay, so the Y value will still become 9, and then the next one would be 4. Right, so my Y values don't change, 9, 4, 1, 0, 1, 4. If you're doing the tables, right? But my X's do change because of what we did. So let's look at the values of X, right? So again, what did I say for this one? That was, it was -3 multiplied by 2 became 6, add 1 is 7. Next one, multiplied by 2, it's 4, add 1, it's 5. So these are new points for the transformed of this graph. So now if you plot those points, there you go, start plotting them here. So I'm gonna play it from here so you can see. See, it started on this side and it's stretching.
1, and then the point 1, 0 was my vertex. And then my last 3 points, -1, 1, right on top of there, -3, 4, -5, 9. -3, 4, -5, 9. Connect those points with a smooth curve. And you'll notice what we have here is our graph in red of the function g at x, the transformed version of f at x.
Right, you can see how it moved it over by 1, and you can see how it's pulled apart, stretched, okay, on the Y and the X axis. So now let's do another one, okay? What else is he gonna talk about? Let's see.
It's been shifted 1 to the right. Notice the vertex is 1 unit right of the original one, and it looks like someone has horizontally stretched it, right? They've grabbed that blue function on either side and stretched it out horizontally. So there's the graph of our transform function. And we've listed the key points.
Okay, so the key points is when you go back to your transformed, it's easier sometimes just to do the table and look at your original and then see how it's transformed from the original, right? And since it was no effect on the Y, you can see the Y stayed the same. All the effect was happening on the X coordinate, okay? Next one. So here is another one. Here's a radical, right? And then the radical looks like it's going to shift down. Looks like it's going to shift down by -1. And looks like this is a +3. That means it's going to go to the left by 3. And I see there's a 2 there, so it's going to stretch by 2. And I see there's a negative, so that means it's going to be a horizontal, a vertical reflection. That's what I meant to say, a vertical reflection. So let's look at it.
The function root x is going to look different than a quadratic. I don't know if you've ever worked with this function before, but let's figure out what it looks like by choosing some key points for the function f at x equals root x. So to figure out what it looks like, I have to choose values for x that I can actually find values for y for. So I can't put -3 in for x because the square root of -3 doesn't exist. So we can't do that. I need to choose, I don't need to choose, but it would be nice to choose some perfect square numbers because then we'll get nice integer values for y. So I'll choose 0, 1, 4, 9. Those are all perfect square numbers, right? The square root of 0 is 0. The square root of 1 is 1. If I square root 4, I get 2. If I square root 9, I get 3.
Okay, so he chose easy points so you can plot, right? So now you can see, and then now we're going to apply the transformation to either x and y. I believe the transformation applies to both x and y for this.
If I plot these points, 0, 0, 1, 1, 4, 2, and 5, 6, 7, 8, 9, 3. I hope I counted that right. There is the graph of my parent function f at x. 1, 2, oh, I didn't count it right. Let me graph it again quickly. 1, 1, 2, 3, 4, 2. I plotted that one in the wrong spot. 5, 6, 7, 8, 9, 3. There we go. That's better. There is the graph of my parent function f of x equals root x. That's what it looks like. And notice I only put an arrow on the right side. Why didn't I put one on the left? Well, the function doesn't exist to the left. It doesn't exist with negative x values. The domain, x can be any real number. Given that, it's greater than or equal to 0. I can't plug in an x value less than 0 and get a value for the function. It doesn't exist. Can't square root a negative number. So that's what the parent function looks
Okay,
like.
so now we talked about that's the parent function. So let's look at transformation now. Okay, that's the transformation, right? The parent function we just graphed. Transformation, it's going to go down. It's going to go down 1 on the y. It's going to go to the left by +3. Okay, my x is going to go. It's going to go to the left +3, and then my my y is going to be stretched by 2, and it's going to be inversed by negative. Okay, so let us fast forward that. There's your transformation values. Okay, so again, a is -2, vertical stretch by a factor of 2, and a vertical reflection, like I said. And then d is actual -3, so it's going to go to the left, like I said. And then c is -1, so it's going to go down, like I said. Okay, so what he's going to do is go back to the table and then put the new table values, right? He's showing you over here on the side there, you can see, right, how it would transform in the actual function. So all my y values, I'm going to multiply by -2. All my x values, I'm going to subtract 3. And all my y values, I'm going to subtract 1. Okay, that will give you the new location for each of these points. Okay, so you're going to get something like this on the test, so you should know how to do the parent function and then the new function. All right, so now he's writing the transformation. All the x's going to be -3, and I think all the y's are going to be 2y and then -1. Right, 2y -1. So now all I do is any value I have here for my original x, I -3. So we'll have 1 -3 is going to give me -2. 4 -3 is going to be 1. 9 -3 is going to give me 6. Okay, so that's what I got there. And then for the y values, I multiply by 2 and subtract 1. Well, if I have this one, -2 times 0 is 0, -1 is still -1. -2 times 1 is -2. -1 becomes -3. Okay, and then -2 times 2 is -4. -1 is 5. Right, and the last one, -2 times 3, so it's going to be 7, -7. Should be -7. Okay, I'm going to play it from here so you can see the plot.
Next, -2, -3, 1, -5, 1, 2, 3, 4, 5, and 6, -7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So here's what it looks like. Be careful where you put the arrow, right? It's been vertically reflected, which means the x-axis here acted as a mirror and it flipped across that. So the arrow is still going to be on the right. The function only exists going to the right forever. It doesn't exist to the left.
You should remember how to do this because you'll probably see a question like this on a test. Okay, for this question here.
Left. If there was a horizontal transformation, so if k was negative, it would have flipped the other way and it would have only gone to the left. But there was no horizontal reflection, so the arrow stays on the right. And we should also write the equation for this transformed function g at x. The equation, we just take what's in brackets, replace underneath the square root with that, and put the a and the c values at the front and at the end of the function. So we will have g at x equals -2. Under the square root is x plus 3 and the c value off at the end, not under the square root, minus 1.
Okay, you see that? You need to know how to write that. Okay, so this was the original here. And with the transformations that it was given up top, this is how the new equation looks. Okay. I think the next one is a rational, right? Again, same thing. It's gonna, looks like it's gonna stretch by, well, it's not gonna stretch. It's K is 2. That means it's gonna stretch by a factor 1/2. So that's less than 1. That's a fraction. Therefore, it's gonna be a compression. It's gonna compress by a factor of 1/2. And it's gonna, on the X, it's gonna move then to the left, to the negative side. And on the Y, it's gonna come down by 1, okay? First, we have to graph what does 1/X look like. Okay, so these are the values of 1/X, and figure out the values of Y, and then you can plot it. You can't have a 0 there, so you're gonna have an asymptote. You can't divide by 0. 1 divided by 0 doesn't work, so it's undefined. Therefore, you have an asymptote at the x-axis. Okay, so just gonna graph it. There you go, asymptote at the x-axis, or at x equal to 0. You can say x-axis at x equal to 0. So right, when x is equal to 0, you can never get to x equal to 0. You have an asymptote, so it's gonna look like this. Okay. There you go. It looks like that. Okay.
It looks like if I kept going to the right, it looks like maybe at a certain point it'll get to 0. Maybe it'll even cross over. But actually, that would violate the rule of an asymptote.
So now I just forgot to mention that because when you look at this, y can never equal to 0 as well. So you have an asymptote at the y-axis because the curve can never cross the y-axis, and you have an asymptote at x-axis, so it can never cross the x-axis. Okay, basically you can never get y is equal to 0, and over here x can never equal to 0 because you have undefined. So you have asymptotes x equal to 0 and y is equal to 0. Okay. Again, you can get really, really close. That's just showing you, but you'll never get past 0. So let's go back. So he's gonna let us say, except from here.
We have any vertical or horizontal transformations, so any vertical or horizontal shifts, these asymptotes are would shift accordingly. So if we were shifting left or right, this vertical asymptote would shift accordingly, and if I'm shifting up or down, the horizontal one will shift accordingly.
Okay, so what he was saying there, when you have shifts on the x-axis, I don't mean when we talk about shifts, we're talking about x either moves along the x-axis. So let me, okay, I'm at 7. I'm gonna fast go behind here. Let's see that, so you can see. That's too far. Okay, we'll play from here. Okay, so I'm playing here. So basically what we're saying is when you have the shifts, this is gonna be x is -1, and then this is where the y shifts by -1. So what you're doing basically is moving the asymptotes, right? So the asymptote is here originally for the parent function, and basically -1, that means it's gonna move. This asymptote is gonna move down by -1. And then here the asymptote is x is equal to -1 as well. So instead of x equal to 0, it's gonna move this way. Okay, so you're gonna have your new origin is gonna be down here. Okay. So let's go back just a little bit. I wanted to explain it so you can hear it again.
Horizontal shifts, these asymptotes are going to would shift accordingly. So if we were shifting left or right, these this vertical asymptote would shift accordingly, and if I'm shifting up or down, the horizontal one will shift accordingly. So let's, now that we know what the parent function looks like, let's get points for our transformed function g at x. So g at x, it's equal to f at x.
Okay, so our transform function means when you look at this, our x is only going to change, looks like. Oh no, my bad. So our x is going to multiply by 2 for the x's, and then you're going to add 1. So here it's going to be 2x plus 1. That's what's going to happen here. And over here, my y is just going to be minus 1. You're going to have a y minus 1 over here because it's shifting the y's down by minus 1. Also, too, I should say, you have a minus here. So you're going to multiply your y by a negative. Basically, it's going to basically stretch it. Sorry, not stretch it. It's going to give it a, we call it a horizontal reflection. Okay. So whatever value of my y is, it's going to be now opposite. So if my y was -4, now with that minus is going to be 4. Okay. So let's take a look at that. There you go. Oh, I forgot to add the the 2 there. So I was wrong. There was actually by x you divide by 2. Okay, I forgot to say that. X divided by 2. And then your vertical is -1, okay? Your stretch, -1, and I think there's more stuff he's gonna reveal. Let me fast forward. There you go. Your x, you -1. And then you shift up. Oh, that's actually wrong. Shift, it wouldn't be shifting up because that's a negative. Let's see if he did. Let's see if he addresses that.
Up 1, but c is -1, so clearly.
Yeah.
So c is -1, which
Okay, so he addressed it. So it's not up, it's gonna go down.
tells us we are going to shift down 1. To accomplish that, I would have to subtract 1 from all of.
Okay, so let's look at a graph. Or actually the chart. There you go. So each value of x, you're gonna divide by 2 because your k is 2 and your factor is 1 over k. Okay, so that's why you divide by 2. And then you're also gonna -1. That's a shift to -1 on the x. So that's what you're gonna apply for your x values. And for your y values, you're gonna have a -1, like I said, because it's the minus is in front. And then you're gonna have you subtract 1 because it's shifting down. Okay. So he applies all that, and then we get to our answers for the x's, and then we're gonna have our answers for the y's. Now you can plot the new value, the new graph of the transformation.
So you know our vertical asymptote, instead of being right through x equals 0, it's going to be through x equals -1. Oops, I should use the straight line tool. And I'll do it in red this time. So it's going to be through x equals.
And the reason why is you can see it's -1 because if you look over here, x is -1, but you can never have a y value, right? Because it's going to be undefined, right? Because if I plug in -1, somehow I'm going to have a 0 in my denominator, so it doesn't work. Okay.
is -1 because we've shifted left 1, and you'll notice our function is undefined when x equals -1. And our vertical asymptote, instead of being through y equals 0, it's going to be through y equals -1 because we've shifted down 1. So here's where our vertical asymptote is going to be. And now if I plot the coordinates of the points, you'll see how it works. So -2, -0.
Okay, so it's going to plot it so you can see how it looks.
So this side of the function is going to look like this. There's our transformed function, g at x. And just to make a note for you, well, let's write the equation first, right? To write the equation of the transformed function, we just
Okay, so the equation of the transformed function, right? That's the original equation 1 over x is just going to be, you're going to just take this and you're going to put it there. You're going to put it underneath this here. So watch.
take what's in brackets, and we replace the x in the equation with that. So, and we put the a value in front, so we could put the -1 out front, and then multiply that by 1 over 2 times x plus 1, and put the c value off at the end, -1. That looks a little cluttered. We can multiply this a value into the numerator, and how I would write it as -1 over 2 times x plus 1 with the c value -1 off at the end.
Okay, so that's how you'd write that. Okay, I believe we are done with that. So let me go on to the next. So let's see, and you got the worksheet for that. Okay, let's go look at an assignment just to see what the questions look like. All right, so here are examples. Okay. So here are all the transformations. Okay, here's your, you're gonna have your parent function. And what does it look like after it's transformed? Right, by these values here. So you're gonna practice that. And you're gonna also practice this one here when it's given like this. What does the transform function look like? Okay. So video lesson, this is solving for quadratics. That means finding the x-intercepts. So let's look at that one. I think you guys should have did that in grade 10, to be honest. That's what it sounds like. Or sorry, no, maybe not.
Okay, here's the first part of the lesson for section 1.5, solving quadratic equations for the grade 11 functions course. The first part, I'm going to teach you how to solve quadratics by factoring. You would have learned this in grade 10, but this is just a quick review, and I'm going to hopefully show you a nice trick for long factoring that you may not already know, that'll save you some time. And then part 2 of the lesson, which I'll post later, is going to be on solving using the quadratic formula, which you would have also done in grade 10, but this time I'll teach you how to leave your answer as exact. To find the x-intercepts, and to find the x-intercepts, or to solve a quadratic, the quadratic has to be in standard form, and it has to be set equal to 0. So that means sometimes you may have to rearrange before you solve. So let's go ahead and get started. So you'll probably remember from grade 10, when factoring a quadratic, there's two scenarios. Scenario 1, the coefficient of the x squared is a 1. And generally that is the easiest type of quadratic to factor. You can usually go right to your answer once you find the appropriate product and sum. The harder type is when the coefficient of the x squared is not 1. We'll do a couple of those.
Okay, so basically you can use product and sum. You can use product and sum to figure this out, right? Or you can use any of the other factoring processes that you learned in the past to figure this out. Because that's all you basically want to find out is turn this into a factored form. Okay, so here is using product and sum. Okay.
This is not a stand mixer. It's how the Harpers turn downtime into together time. And this is not just any loyalty program. It's one made for them. Because with Triangle Rewards, you get personalized offers every week. Download the Triangle app today.
Okay, so now you got the two numbers would be -8, -7. Okay, then you're just gonna rewrite it. That's in factored form, so y is equal to that.
To 0, we're setting the y coordinate to 0 because we're solving for the x-intercepts.
So if we're solving for the x-intercepts, we set the y equal to 0, so therefore x can be 8 and x could be 7. Because when you have x is 8, this whole thing is 8, or this whole thing is 0. 0 times anything gives you 0. If this is 7, that means it's going to be 7 minus 7. It's going to equal to 0. So anything times 0 is still 0. So it works out.
X could be 7. So our x-intercepts are 8, 0 and 7, 0. Those are the two places this quadratic would cross the x-axis.
Okay, so let's fast forward. Looks like it's going to go through some examples. Again, these, I don't need to go through this because a lot of this stuff is just setting it to 0 and then figuring out what then turning it into factored form and then figuring out what the the x-intercepts are. Okay, so we'll just fast forward this. This is again product and sum. This would be probably -3 and -2. Okay, and then that would be your answer. So you set it x to, like, in order to find what that x-intercept is, just take this one, x minus 2 equals 0. Then you're gonna have your x is equal to 2 and x is equal to 3. Okay, so let's continue. This one here, it's a special way to factor, right? So again, we do product and sum. So you're gonna have 2 times -42. So that would be, I guess, 84. So two numbers that multiply together to give you 84. And then when you subtract them, you get -8. So let's see what that would be. Oh, actually, there's another way too. You can take out the 2 because everything's all easy divided by 2. So you can take out the 2 and then factor the stuff inside. So that's what they did. So now you can get two numbers. That would be -7 times 3 gives you -21, and -7 plus 3 gives you -4. Okay, there you go. That becomes your x-intercepts. Okay, just like that. So let's go on to this. This is when A cannot be factored out. And I believe you can probably do factor by grouping. Okay, there you go, factor by grouping. So you guys remember that? I'm not sure if you guys remember factor by grouping. So let's take at it.
2. I should remind you that you always should have checked for a common factor first, but there is no common factor between 8, 2, and 15, so I couldn't take anything out. So we have to factor it the long way. We find a product of two numbers that have a product of 8 times -15, so a product of -120, and a sum of your middle term, your b value of 2. And the two numbers that do that are
the two numbers that do that are 10 and 12, right? So 10 and 12, 12 minus 10 gives you 2. 12 times minus 10 gives you 120, okay? There you go. So in fact, okay,
A smile can make a big difference for your health. If you have kids under 12 and an income under $90,000, you may have access to the Canada Dental Benefit. Now that's something to smile about.
Today I'm plating something special, not for my customers, for my cat. Fancy Feast obsesses over food like I do, with delicious little details and one extra ingredient. Love. Fancy Feast. Love is in the details.
Equal to 0.
Okay, so what we're doing here is when you have the two values of the product and sum, so you got 12 and 10. If you remember this is grade 10 stuff. This is grade 10 stuff. If you remember, you just basically separate the two like that. It doesn't matter if you put the 10 with the 8 or the 12 with the 15, doesn't matter, you still get the same answer. Okay. And then you put a bracket around them and then you factor by grouping. You guys remember? I'm gonna just play it from here so you can see it.
You would have put the last two terms in brackets and you would have separated with an addition sign. And then you would have common factored each group and then factored by grouping. So common factor this group, you could take out a 4x and divide both of these by the 4x you took out, 2x plus 3. This one you could take out a -5, divide both by the -5 you took out, and once again you would have 2x plus 3.
Okay, so you do that, and then so you can see the factors are going to be 2x plus 3 times 4x minus 5. Okay, those two become together. Now you figure out what is my x-intercepts. You set these ones to 0, and then you can solve for x, and that would become your x-intercept. Okay, there you go. Okay, so that's the answer.
-3 over 2. Your second x-intercept, move the -5 over, becomes 5, divide by 4. You get, for your second x-intercept, 5 over 4. Now, that is a very long way to factor that quadratic.
Okay, so let's go on to the next one. I guess it's going to show you a different way to factor, but factor by grouping is this. It's basically try and tested. So I wouldn't do any other way, but you should see this one gets complicated now, so I don't want to show you that. He's doing it a little bit complicated way, so I'm going to fast forward that. Okay, so what's the next question? Give me a second. I'm looking for the next example I meant to say. Okay, here's another example. You can see something like this. 2x minus 11x equals to minus 15. You're gonna have to set the minus 15 over to the other side and equal to 0. Okay.
When solving quadratic, you must set it equal to 0. So I need to move that -15 over, it becomes a plus 15. Now I need to find two numbers with a product of, well, first of all,
Like, okay, so I know he's about to say, he's gonna say, first of all, can you factor out the 2? You can't factor out the 2. 2 does not go into 11 or goes into 15 evenly. So as a result, you're gonna have to do factor by grouping. So what two numbers that multiply, is there even two numbers that multiply give you 15? And then you subtract them together, you get -11. Let's see what happens.
check for a common factor. 2 doesn't go into 11 or 15. We can't take out a common factor, so we're going to have to factor it the long way, which we discovered on the last example isn't actually that long. So we define two numbers with a product of 2 times 15, so a product of 30, and a sum of -11. Sorry, it looks like a 36 kind of.
I've been telling everyone, the secret to great teeth is having healthy gums.
Crest Advanced Gum Restore fights plaque bacteria below the gum line, promotes gum healing, and restores gums back to health. Crest.
Okay, the two numbers that multiply to 30 and add to -11 are -6 and -5. -6 times -5 is 30, -6 plus -5 is -11. And hopefully you remember from the last time what I'm going to do with these two numbers, the -6.
Right, so basically those two numbers now are going to be your the numbers you're going to use. to do the factor by grouping. I hope he's doing factor by grouping. Yeah, he's doing the other way, which I don't like. Factor by grouping. Okay, I'm gonna write this on the screen because he's doing it the way I don't like to do it, because I think gets confusing. So let's go back and do factor by grouping, and then you can see what the answer is. I'm gonna do this on the screen here. So I have -6 and -5, so I'm gonna have here 2x squared. And it doesn't matter which one I put with what, but maybe it's better I put the -6 with the 2. So I'm gonna have here -6x and then -5x with the 15. Set that equal to 0. Okay, I put brackets around here. And these two, I'm gonna have to take that negative, bring it over to there with that. Okay, so my bad. And I'm going to have to take the negative in there, so it's gonna have to be a plus afterwards. So let's just do that again. 2x minus 6x plus 2x squared. And I bring that negative inside, so this is gonna be a plus. And inside here would be -5x -15 equals to 0. Okay, so I'm going to factor out here my 2. I can factor out a 2. Oh, and actually, my bad. I didn't need to take that. I didn't need to do that because we're gonna factor that out anyways. So I can factor out the 5 here. So I can bring the 5 outside with the negative, it's fine. And then you have x plus 3 equal to 0. I still gotta factor out the 2 here. I can factor the 2 and the x here. So it's gonna be 2x on the outside, and I'm gonna have here x. And see, it doesn't really matter. I'm gonna have here -3. Actually, it's gonna be, did I make a mistake somewhere? That's a negative. So I factored that out, it would just be a, something's not right here. If I do that, just hold up, guys. I made a mistake somewhere. 2x, and then you got here x, and that's a negative. That's going to be like that, which doesn't work out. Did I do something wrong here? Okay, that's that. Factor out. Oh, okay. This is what okay. So I made a mistake here. I made a mistake, and the mistake was over here. Okay. That's where the mistake is. I should apply that on the inside as well. So it should be negative x 5x, and then this should be a -15. That should have been there. I made a mistake. Okay, so now I factor out that's still going to be off. Okay, maybe the question is written the way that doesn't make any sense. Let me just clear the screen and then just see what he does. I'm going to fast forward a little bit. Okay, so it's -3 what we had. Oh, negative. Okay, I guess I made a mistake somewhere. Sorry, guys. But that's basically, you could do it by factor by grouping as well. So that's what he got the same answer. So I was looking at 2x and I had -5. Either way, it's the same. I'm dwelling on this and wasting time. Let me fast forward. So we're looking at solving again the So finding roots. So this the other, you get to learn some of this terminology. Finding the roots of a quadratic is the same thing as finding the x-intercepts. Okay, so what's the x-intercepts of this is basically turning that into factored form, and then you can figure that out. So like we did there, set it equal to 0. Okay, and then you're gonna factor out anything you can factor out, and after that, then do product and sum, or do grouping. In this case, you're doing product and sum. So my roots are going to be x is 4 and x is -2. In other words, it's my x-intercepts as well. Now find the axis of symmetry. Well, finding the axis of symmetry is the middle difference between your x-intercepts. So in this case here, the middle difference between 4 and -2. Okay, so basically you add the 4, you add the 2 x components, and you divide by 2, will give you the axis of symmetry. In other words, it's going to give you the average x-intercept. Okay, so when you finding average, you add 2 numbers divided by 2, right? That's another way to look at it. And then find the coordinates of the vertex and state if it's a min or max. So the coordinates of the vertex has to do with the axis of symmetry. Okay. And then what's the y value of the vertex? Well, if my axis of symmetry is at 1, I plug in 1 into the original equation, and then I find what x is, or find what y is. So that's what I did there, right? I'm going to plug in 1 into this original equation, and whatever I find for that value, that's going to be my vertex for my y, and then my vertex coordinate is going to be 1, comma, whatever this value is. Right, so my vertex is at 1 and -18.
1, -18, and since
okay, so that is that video. I'm going to go to, we don't have much time. I just want to see what the next lesson is. Here's those are the questions. The next video is just basically using the quadratic formula, right? Basically use the quadratic formula. I won't go into it. This is the quadratic formula right here. And you use the quadratic formula to find the x-intercepts, right? Sometimes your product and sum may not work. Sometimes your factor by grouping doesn't work. So your last resort is to use the quadratic formula, okay? So the quadratic formula is the last resort if you can't factor by grouping or factor by product and sum, okay? Because if you look at this question here, 3 does not go into anything here. You got a 7 and a 5. These are weird numbers. They're not factorable numbers, so it won't work. Okay, so you probably have to use the quadratic function for that. Okay. So, and then you got questions for that. And then the last one is this one here. Where your quadratic and linear system cross. Okay, you can go through that video. And then you got, here's the lesson portion of it, and then you got questions. I know guys are gonna say, oh my gosh, that's so much work. It's just, there's nothing else I can say. That's just how the course is. It's really nothing you can say about that, right? The test is open now, but you can't do the test unless you practice these things. And then once you practice these things of which we just talked about, linear system, the roots, then you should do the quiz for today. You still can't see the PDF of the test? Okay, if you can't see the PDF of the test, I'll fix it later, okay? I'm gonna fix it right after this call, this Zoom session, okay? Oh, you could see it now. Okay, I told you, refresh your screen. So there you go, it's there, okay?
Wait,
but again,
no, sorry, I was looking at the functions. I can't see the quadratic functions test.
okay, that's fine. I'll take a look at it and see why you guys can't see it. Actually, If I can see it, you should be able to see it. Let me just look at it here. Because if I can see it, and I can see it right here. So I don't know what's going on. I can see it. I can click on it. There you go.
There's no PDF link attached to it.
Oh, that's the problem. My bad. Okay, my bad. I thought there was. Okay, there is. Yeah. Okay, so I'll fix that. I'll fix that. Okay. Let's see here. So the test you do is due tomorrow, okay? Or was it? Yeah, it's due tomorrow. Right? Wednesday at midnight. So that's not the first thing you're doing. The first thing you're doing is not doing this test. The first thing you're doing is doing the quiz, and then you're going to be doing the collimating. Or sorry, the review. The review doesn't count for marks like it says there, but it helps you, right? And maybe do the worksheets. Okay, so I believe we're running out of time, so I'm going to stop sharing my screen. We start early. That means you have more time during the day to get stuff done. That's part of the reason why I want to start at 9. Okay, so I'm going to stop recording.